Hello, good evening, everyone, and welcome back to another session in this late night qualifier series. And in that, I welcome you all to the session on stability of floating body and fluid acceleration. I'm Vikas Sir, and I welcome you all to this session. So, one session has already been conducted in this late night series in the subject of fluid mechanics, and today is the next session, another session. I welcome you all. And welcome back. Welcome you all to this session, everyone. So good evening everyone and welcome to this session on stability of floating body and fluid acceleration. Basically, whatever topics we are covering in this late night series, all the topics are given in the GATE syllabus and all are very important topics. Hi Jigar, Ghazar, very good evening, welcome to the session. So everyone, good evening and welcome to this session. Hi Vikas Yadav, very good evening, welcome to this session on stability of the floating body and fluid acceleration. These two topics have been given as it is in your syllabus. So that is why we'll be studying these topics today. Hi Arnava Gupta, very good evening. Hi Nitish Kumar, good evening. Aman Suneja, very good evening. Good evening everyone and welcome to this session. I hope you guys are doing good and I hope your new year was fantastic, awesome. So last time we met was on 31st and I hope that you had a very amazing Happy New Year celebration with your family, with your friends. So very happy new year again I would like to say because last time I think we met on 31st. Hi Ajit, very good evening, welcome to the session. Hi, good evening everyone, welcome to the session. And those who have joined me for the session, please also like the session and share the session also so that we can have more participants in the session. Yes everyone, quickly join for the session. Hi Mohit Kundu, very good evening, welcome to the session. So we are, I can see we are having 15 students who are live, but I can see only 7 likes in the session. So please, guys, please also hit the like button. Take out some time and like the session and also share the session. Okay. Today in this session, we are going to study about the stability of floating body. As it is, this topic have been mentioned in the GATE 2021 syllabus and fluid acceleration. These two topics have been as it is mentioned in the syllabus. So that is why I will be covering these topics. Hi Srinivas, good evening. Hi Krishna Kumar, very good evening. Welcome to the session. So guys, those who have joined me, very good evening everyone. And also please like the session, share the session and subscribe our channel. Let's begin the session. I would like to start with my introduction. First, I'm Vikas Sir. I have 5+ year teaching experience. I did my MTech in thermal engineering from Thapar University and mentored more than 10,000 plus aspirants for different exams like GATE, ESE and SSC. My area of expertise basically includes subjects of fluid mechanics, thermal applied and heat transfer subject. So good evening. Once again, I would like to say good evening to everyone. Hi Shaumitra, very good evening. Good evening to all of you and welcome to this session. Now let's start the session. So my dear students, before we understand the stability of floating bodies, I would like to point out your attention towards a very important principle given by Archimedes that most of you also know, that when Archimedes was doing this experiment on when he studied the stability of floating body and fully submerged body. So what experiment he was doing on that point of time? He was basically resting in his bathtub and he was suddenly he experienced something which he called as the buoyant force. Okay, and that buoyant force you must have also experienced if you have a bucket full of water and if you try to put a mug into the bucket, you will feel that a force is getting applied in the opposite direction in which you are applying if you have a bucket and you want to dip that bucket into a bucket, if you have a mug and you want to dip that mug into the bucket full of water, you will find that equal and opposite force will act in the opposite direction in which you are trying to dip the mug into the bucket, right? So that is only happening because of buoyant force. That is a force which is experienced by the body which you are trying to submerge inside the fluid. So what does Archimedes principle says right now? If you want to see here, if you can see in this diagram, let us say we are having this is a weight balance. This is a weight which is 5 kg weight hanging on a spring balance. You can see that. Now, this is a bucket full of water. It is having an opening right now here. Okay. So this is a bucket, we can say this is a vessel which is having some quantity of water, and on the side we are having an empty small container. Okay, now suddenly what we can do is we can just put this weight having 5 kg or mass having 5 kg into the water. So as soon as if you put this body having mass 5 kg into the water, you will experience that what you will experience is suddenly the reading on the weighing balance will go to 3 kg. It will show you the reading of 3 kg. Why? Why it is showing you the reading of 3 kg? Because there is some change which is definitely happening in this when the body is in air, when body is in air, and the body when it is in water, when your body is submerged in water. There is some difference which is taking place. So what difference is taking place? Basically, if you notice that when the body was in air, when this mass was in air, it was having the weight of 5 kg or mass of 5 kg, or if you multiply that with 9.81, it will be 5 into 9.81, right? Or 50 Newton, you can say. But if the same body is immersed inside a water, completely immersed inside water, what you will see, the weight has suddenly dropped to 3 kg on the spring balance. Why? Why it has been dropped? Because of a phenomena which is called as buoyant force. Because when this weight have been dipped inside this bucket, some liquid will start to drop inside this. When you will start to dip this mass which is having 5 kg into this bucket full of water, some water will start to pour into this container. Let us say 2 kg of water has basically got displaced. This is the volume of water displaced. Volume, or we can say to be very precise, mass of water displaced. Hi Kamran, very good evening, welcome to the session. Let us say this is the mass of water displaced. This is mass of water displaced. How much mass of water displaced? That is equal to 2 kg. Okay, so what is happening right now, basically what you will notice here is that when you dip this mass into this, there will be a gravity, that is the point of where the whole center of where the body force will be acting, that is center of gravity, and there will be some point in this hole on the body where an equal and opposite force, there will be some weight which will be acting downward, which will be equal to 2 kg, let's say, and there will be some equal and opposite force which will be acting, and that will be the buoyant force. There will be a force which will be acting, that will be buoyant force on this body. Okay, what is this buoyant force? So what does Archimedes principle tells us? Whenever a body is immersed in a fluid, either partially or fully, whenever we immerse a body in a fluid which is either partially immersed or fully immersed, it will experience a net vertical force which is known as buoyant force. And this buoyant force, my dear, will be equal to weight of the fluid displaced by the body. In this particular condition, you can see 2 kg of water has got displaced. 2 kg of water have been got displaced when this weight of 5 kg have been dropped into this vessel full of water. Okay, so we can say that the buoyant force will be equal to weight of the displaced fluid, and it acts upward through the centroid of displaced volume. Okay, so basically if you see this container, let us say we are having a body, and this body is, let us say this is the body completely submerged. Okay, so there will be point of center of gravity at which the weight will be acting, and there will also be point of center of buoyancy at which the buoyant force will be acting on the body. Let us say this is the point of center of buoyancy at which buoyant force will be acting upward. So buoyant force will be acting at a point which is called center of buoyancy. It is center of buoyancy at which the buoyant force will be acting. And what is the center of buoyancy? Center of buoyancy is defined as it is the centroid of displaced fluid. It is the centroid of the displaced fluid, that is called center of buoyancy. Okay, clear everyone? Now let you see this example, or let us say this is a body which is dipped inside this, which is having some volume V. Okay, so according to Archimedes principle, a buoyant force will be acting in the opposite direction and the weight will be acting downward direction. So according to Archimedes principle, for a body which is fully or partially immersed, the weight of the body will be equal to the buoyant force. will be equal to the buoyant force. And buoyant force will be equal to what? This buoyant force is equal to, the buoyant force will be equal to the weight of displaced fluid. Weight of displaced fluid. The fluid which have been displaced. Generally we know that the weight of the displaced fluid, weight is equal to mass into acceleration due to gravity, right? So weight of the displaced fluid will be equal to density of the fluid into the volume of the displaced fluid into acceleration due to gravity. This will be the buoyant force. Okay, this is a very important condition. We'll be getting that the buoyant force will be equal to weight of the displaced fluid. What is the meaning of displaced fluid, my dear? The weight of the displaced fluid means that fluid which has got displaced when that body was dipped inside that or submerged inside that fluid, either fully submerged or partially submerged. Okay, now there are two important things that Archimedes principle tries to tell you. One is volume will remain same. No, volume will not be same. The volume of the displaced fluid is different than volume of the body. Okay, so what we can say that under equilibrium condition, the buoyant force, the weight of the body will be equal to buoyant force will be equal to weight of displaced fluid. So I will tell you when this condition will happen, when this condition is going to happen, when weight of body will become equal to the buoyant force. Now weight of the body will be equal to density of the body into volume of the body, the whole volume of body, into the acceleration due to gravity. That is the weight of the body. But weight of the displaced fluid is different. It is equal to density of the fluid into volume of displaced fluid. What is the meaning of displaced fluid? I will tell you with the help of an example. Okay, let us say that we are having a hi, good evening Prateek, very good evening, welcome to the session. Let us say we are having a body which is, let us say it is partially submerged inside water. It is partially submerged inside water, and so what will happen? Let us say this is a free surface. This body is partially submerged. It is having some height. Let us say dimension of. Let us say this is. Let us say d. Okay, and this is. Let us say it is equal to b. Clear? It is having the width of b and the diameter of d. The height of d. Let us say. Now, what is the meaning of displaced? So, what is the total volume of the body? Volume of body will be equal to the area into the height. Height is equal to d here. Okay. And what is the meaning of volume of displaced fluid? Displaced fluid means this fluid which is dipped inside, which is kept inside. The volume of the body which is inside this. To find the volume of displaced fluid, we have to find this height. What is the height dipped submerged inside water? This height you have to find, this h. Okay, then you will be getting the volume of displaced fluid. So volume of displaced fluid will be equal to the area into the h. This h you have to multiply with right now. Okay, so that is the difference. You have to find this height, this amount of the body which is submerged inside the fluid. That height you have to find in that case to find the volume of displaced fluid. That is the difference. Okay, also the area, or finding the area, this height will be taken and this will be the dimension. Clear? So in that case, this will be equal to h into b into h, and here it will be equal to d into b into d. Clear? This will be the area, this will be the h. Clear, everyone? So this is how we will be finding the volume of the body and volume of the displaced fluid. Displaced fluid means that fluid which is displaced, which is placed inside the water. Because of this portion of the body, because when this portion of the body has been kept inside the water, then some liquid has got displaced, definitely got displaced. So that volume of this body which is inside the water, submerged inside the water, will give you the volume of displaced fluid. So there are two types of basically bodies that Archimedes was talking about. One was a floating body. Another is a fully submerged body, floating or partially submerged. partially submerged body, like in the case of a ships. If you see the example of a ship, it comes under the partially submerged body. But if you take the example of a submarine, it comes under fully submerged body. Okay, submarine comes under fully submerged body, the body which is fully submerged inside some fluid. For example, submarine. Okay, so there are two types of bodies which Archimedes was talking about. One was fully submerged, other was partially submerged or floating body, for example ships. Now in your syllabus only floating body is given in the syllabus, only floating body. You don't have to study the stability condition of fully submerged bodies. Earlier they used to give the submerged body also, but now they have only mentioned about the stability condition of a floating body. Okay. So my dear, there are three cases which I would like to point out here. There are three cases which we have generally studied. One case is, you can see the first case. In the first case, case number A, if you see the diagram very carefully, there is a container and there is a body. This is a body. Now this body is completely submerged. It is a completely submerged body. So when can we say that the body will be completely submerged? It is a completely submerged body. When can we say that body will be completely submerged or it will be a floating body? What are the conditions for that? What are the conditions that a body will become fully submerged? Or see, my dear, those who have joined me for the session, please also like the session also. Okay, please give some time to like the session. So what are the conditions for a body to be said to be a submerged or floating body? In the first case, if you see case number A, in this particular situation, if the density of the body is greater than density of the fluid, if the body which you have to submerge, if that density of that body is more, if a body is more denser than the fluid in which it has to be submerged, in that situation the body will get completely submerged inside the fluid. Okay. For example, if you see the example of a submarine, submarine has more density. The body of the submarine will be having more density when there is no part visible above the free surface of the body, then it is called completely submerged body. See, I have shown you the example of the completely submerged body. Body which is completely submerged are having two cases. Okay. There are only two types of body, Pratik. One is the partially submerged, one is completely submerged. Partially submerged means some part of the fluid will be in air, some part of the body will be in air, some part will be in water or the fluid. And partially submerged, fully submerged means the body will be completely surrounded by that fluid. Okay. Yeah, I Noob 2 Pro in live YT, quite a unique name, my dear. Yeah, good evening and welcome to the session. And yes, very happy new year. I hope you also have a very fantastic new year. Okay. In the first particular case, if you see the density of body, if the body becomes having more density than the body in which the than the medium in which the body has been filled. Suppose we are having a body and that body is having more density, and if that body has more density than the fluid in which it has been placed, then that will be the case of completely submerged. In that situation, the body will not only get submerged, but it will rest at the bottom of the body. Okay, you are Ashwin. Okay, Ashwin. How are you, Ashwin? The second case is also a case of completely submerged, but in this case the density of the body is equal to density of the fluid. If the density of the body will be equal to density of the fluid, in that particular condition, what will happen? It is also a completely submerged body, but in that condition this case will happen. This is a case. Then in that condition the body will be just touching the free surface. The body will be in contact with the free surface. That is the condition of submerged body, but it is also a condition of a completely submerged body, but the top surface of the body will be in contact with the free surface. Okay, that is also condition of a completely submerged body. But in this condition, density of body is equal to density of the fluid. The last condition is if the density of the body is less than density of the fluid. If density of body will be less than density of the fluid, in which it has been kept, then definitely the body will be a floating body. This is a condition of a floating. Okay, so we have to study this condition. This is the condition we have to study, floating body condition. So when a body will be floating, when can you say body will be floating or submerged? A body will be floating only in one condition, if the density of the body, if I want to give the example, a perfect example is your ship. Okay, the perfect example of a floating body will be ship. For example, in the case of a ship, if you notice, let us say we are having a ship. If you notice one more important thing, that the ship generally floats in water. So what happens? If you can notice one thing, that the upper part of the ship generally remains hollow. The upper part of the ship generally remains hollow. Okay, this is a hollow portion, while the lower part of the ship remains a solid body. Can you understand the meaning of that? Okay, density of the ship, density of the steel is greater than water, but ship float on water. Try to understand it. That is the reason I want to tell you, Nitish. The ship has a hollow shape on the top and a solid portion on the bottom. So I totally understand that ship has it is made of some material which will be having more density than water, but the ship is hollow in the surface on the top and only solid in the bottom. So that is why only the bottom portion of the ship is submerged in the water, which is submerged in the water, while the top portion will be having less mass and will be having less density because it is a hollow portion. Okay, so upper body is hollow, while lower body is a solid body, and that is the reason that only the lower portion of the ship is submerged in the water while upper portion remain above the water. Do you get this point or not? Some of you are asking this question, sir, why is it possible that ship is able to float on water? Because it is also made of some material which is having more density. The simple meaning is that the material having more density remains submerged. Okay, material under it is, yeah, exactly, because of the design it floats on water. Because have you ever noticed that when ships get basically submerged in water? Have you noticed that condition? It is a condition when this lower portion, when this upper portion, if this becomes like this, if the ship becomes like this, that is hollow portion comes in the bottom and the solid portion will come on the top. Under that situation, the ship will get completely submerged. It will get completely submerged. Okay. If this hollow portion will go in the bottom and the solid portion will go on the top, and that is the reason when if you have seen some movies when the ship basically turns into the water, okay, and it gets submerged, it is only possible when the top portion of the ship gets dipped into the water and the lower portion comes up, right? That is how the ship dips into the water. That is how basically कहते नहीं है डूब जाने को क्या बोलते हैं, it dips into the water, gets submerged into the water. If you have noticed this phenomena, are you getting my point? That is because of the metacentric instability. But one more reason is that when the upper portion will come on the top, then density of the body will become greater than density of the fluid. Under that situation, the body will become submerged. So in this situation, the body will get submerged if the lower portion of the ship will come on the top and the upper portion will come on the bottom. Then definitely you cannot protect your ship from getting submerged. Okay. So if you guys are asking that ship must be having some material which is having more density, yeah, that is correct. Ship has a material which has got more density than density of the fluid, but still the ship is able to float. Why? Because the high density material is on the bottom and the hollow portion is on the top. Okay. As ship sinks downward, then volume of submerged increases and hence buoyant force increases, due to which ship will float. Clear, everyone? So that is the main phenomenon that I have to tell you. No, so the last portion is that density of body should be less than the density of the fluid. If the body has to be partially submerged or float. Okay, that is the important condition. So under floating body, for floating body, the weight of entire body must be equal to buoyant force, which is the weight of those fluid whose volume is equal to volume of the submerged portion of body. So under floating body, this condition will be applied, that weight of body will be equal to the buoyant force under floating condition. For floating condition, this condition will be satisfied. Okay, or we can say that weight of the body will be equal to weight of displaced fluid. Okay, this condition will be used under floating condition. Displaced fluid means that fluid which is placed inside water, that is the display, that portion of the body. If you have to find the weight of the displaced fluid, you have to find the volume of that portion of the body which is submerged inside the fluid. You have to find that volume. Okay, that is a very important. Yeah, this is also the principle of flotation. It is also called principle of flotation. Very good, Prateek. Clear? Now, my dear students, I have to tell you about a very important thing that is important. What is the meaning of center of buoyancy? The buoyant force that I am talking about, that is weight of the buoyant force is equal to weight of displaced fluid. What is the meaning? What is the point of application of that buoyant force? The point of application of that buoyant force, सर अगर मेटासेंटर buoyancy सेंटर के ऊपर आएगा तो फ्लोट करेगा. Metacentric buoyancy के see, if we talk about the stability condition of a floating body, then we don't have to, the only thing which is important is metacenter. Okay, if metacenter is above center of gravity, then the body will be a stable equilibrium. I will tell you the stability condition, don't worry. Before that, you need to understand what is center of buoyancy. Center of buoyancy is the point of application of the buoyant force, and it coincides with the centroid of the whole submerged body of homogeneous composition. The center of buoyancy is also called the centroid of displaced fluid, or centroid of the body, centroid of the displaced fluid. The centroid of the displaced fluid, okay, or centroid of the body, centroid of the body placed in the fluid. You can say that centroid of the body submerged in fluid. That will give you the center of buoyancy. If you have to find the center of buoyancy, you have to find the centroid of the body of that portion of body which is submerged inside the fluid. That will give you. For example, if you see this is your ship, let us say this is your body. It is submerged inside the fluid. Then what is center of buoyancy? Center of buoyancy is actually the center of gravity. It is actually the center of gravity or centroid of the. It is the center of gravity or centroid of that portion of body which is placed inside the fluid. So this is a body, this portion of body, this portion of body which is placed inside the fluid. The center of gravity of this body, this portion of body will be equal to center of buoyancy. Okay, and the center of gravity is equal to what? Center of gravity is equal to it is actually the centroid of the whole body. Centroid of whole body is the center of gravity, and centroid of the body which is submerged in the fluid is the center of buoyancy. Okay, clear everyone? So the buoyant force will be acting at this point. This point is the point at which the buoyant force will be acting, that is at the point of center of buoyancy. And the gravity, G is the center of gravity at which the weight will be acting downward. Clear everyone? Please give me the fluid mechanics 2 playlist, sir. Vikas, this is the fluid mechanics lecture, and this is also the second part of the fluid mechanics. You can find the playlist in the YouTube section, only. Okay, you can see that. If you search in the YouTube of GATE Gradeup, you will find the playlist. Now let us understand what most of you must be thinking, sir. What is the stability condition of a partially submerged body or floating body? Partially submerged or floating body, what is the stability condition? Because this is given in your syllabus and it is very, very important. So basically I would like to point your attention here that if we talk about a floating body, if we talk about a floating body, then the stability conditions basically point out about one important point which is called metacenter. Okay, so what is the meaning of this metacenter? Let us say we have a partially submerged body. This is your partially submerged body. This is our partially submerged body. So in ideal condition, in the rest condition, what will happen? There will be a point at which the centroid will be acting or center of gravity will be there. This is the point of centroid to center of gravity. I hope you know the difference between centroid and center of gravity. Centroid and center of gravity are same thing for a homogeneous material. If it is a homogeneous material, then centroid and center of gravity are same. If it is a non-homogeneous material, then centroid and center of gravity are different. Okay, so I hope you have studied that thing in engineering mechanics subject, the difference between centroid and center of gravity. But for a homogeneous body, both are same. So let us say this is the centroid or center of gravity of the body, and this is a point of center of buoyancy. For CME, it is for common for civil and mechanical, H. Kumar. Now the center of buoyancy will be the point at which buoyant force will be acting, and center of gravity will be the point at which weight will be acting. This is the ideal condition. In the ideal condition, or this is a rest, this is a normal condition of the body. Now suppose I give some angular displacement. Suppose we are taking example of a ship. Okay, suppose our ship is sailing in the water and suddenly a storm comes in the ocean or in the sea. Then what will happen? The ship will get displaced. It will be having some displacement, angular displacement, little bit displacement will be there. Okay, suppose a ship is simply sailing in the water in the ocean and suddenly a storm comes. Suddenly a storm comes and some kind of storm comes or the cyclone comes in the ocean. Okay, ship is basically sailing in the ocean and storm comes or storm or cyclone. Okay, a storm or cyclone comes, then what will happen? This ship will be having a minor displacement. It will be having little bit displacement or little, like let us say there is a small sea storm in the ocean, and because of that ship is having a small angular displacement or angular tilt. So it will be having a small oscillation or basically small disturbance. So let us say the body has got tilted by a small displacement. The body has, this is a small angular displacement given to the body. Okay, now because the body initially was like this, now the body has got small displacement. Now what is the meaning of stability? Stability means that will the body be able to come to its initial position like this or not, or will the body will get completely dipped into the water? Are you getting a point? Will the body will come to the initial position, or will the body will not be able to come to the initial position, which will get completely submerged? Okay, for example, this is my body. This is my body. Let us say it was floating in the water very easily, and this was the normal condition. Okay. Now suddenly, if I have given there is a small displacement. So there are two conditions. Either this body will come back to this condition, or the body will completely get submerged. Okay, these are the two things which will happen. So my dear students, assume that this body is your ship. Just imagine that this body is actually your ship. Normally the ship was in the stable condition. Normally the ship was in normal condition. It was simply floating on the water. Now suddenly it has got some displacement. So because of this is a small displacement, the ship will get tilted like this. What is the possibility that ship can come back to the initial position like this? Is it possible that it will come back to this position? Let's see that how it will be possible. So when this will happen, then what will happen? Basically, this is the center line. This is the line of symmetry. Okay. So this is the line of symmetry, let's say. So line of symmetry will change now. Line of symmetry will also get displaced. Line of symmetry will get displaced, but this is a point of center of gravity, and this was the initial point of center of buoyancy. This was the initial point of center of buoyancy. But because it is a floating body, so because it is a floating body, what will happen? The portion of the body which is submerged inside the fluid, you can see the liquid, the amount of liquid on the upstream or in the downstream, the amount of liquid which is in which the body has been placed, this liquid will also get displaced. Okay, this liquid will also get displaced, and because of that, I have told you one important thing, that center of buoyancy is what? It is the center of gravity of a displaced fluid. So when the body will get tilted up, the amount of water, for example, this body was in water, completely floating. Okay, let's say this portion was in water. So when this body will get tilted like this, what will happen? Now the concentration of the water will increase. Let us say it will definitely vary on this side and this side. The concentration of water will be different now. Okay, so now it will be having some different concentration. So because of that, the amount of center of buoyancy, the center of buoyancy point will also get shifted. The center of buoyancy point will get shifted in the case of a floating body. This is a new center of buoyancy. This will be the point of this B dash is the new position of center of buoyancy. Okay, now I would like to tell you a very important point. For a completely submerged body, the center of buoyancy is never going to get shifted. For completely submerged body, center of buoyancy will remain same. Center of buoyancy will remain same. It will never get shifted. Okay, it will never get shifted for a completely submerged body. But for a floating body or partially submerged body, when the body will be having some displacement, the center of buoyancy will also shift. Because center of buoyancy will shift. Why? Because the amount of displaced fluid will change. Amount of displaced fluid or amount of the body, portion of body inside the fluid will be changed now. Now some more portion of body will be there inside the fluid. So center of buoyancy will change now. So this is a new position of center of buoyancy. So from the new position of center of buoyancy, if I draw a line, why it will change? It is very simple, H. Kumar, because when the body will get tilted in a particular direction, it will be having some small displacement. So if you notice a ship, when suddenly a small displacement goes into the ship, then what will happen? Some extra portion of the ship gets into water, right? And because of that, more amount of body more portion of body will get displaced will get submerged in the fluid. Because now the more portion of body is in contact with the fluid, the center of buoyancy is definitely going to change, because center of buoyancy is the center of gravity of the displaced fluid, because now displaced fluid is changed now. So that is why the center of buoyancy will also get changed. कभी देखा है आपने कोई बॉडी को, फ्लोटिंग बॉडी को, दिस अ बॉडी व्हिच इज फ्लोटिंग, अगर आप उसको ऐसे कर दोगे तो मोर पोर्शन ऑफ बॉडी विल बी इन वाटर नाउ, द सेंटर ऑफ buoyancy will get changed now. So this will happen in this situation. Now if you draw a line, if you connect this line from the new position of center of buoyancy, and this is a line of symmetry, okay, this is the initial line of symmetry, this is a line of symmetry, this was the initial line of symmetry, and this is a new line which have been drawn from new position of center of buoyancy. These two lines will meet at a point, that point will be called as metacenter. Is it clear to everyone? Exactly. Now you guys are correct. You guys are thinking in the absolutely correct direction now. When the body will be completely submerged, no matter whether the body is getting displaced or not, the body with center of buoyancy will remain same. Only in that condition, for a completely submerged body, it will depend on the position of center of buoyancy and center of gravity. What is the position of center of buoyancy and gravity? If center of buoyancy lies above center of gravity, the body will come back to the initial position. If the center of buoyancy lies below center of gravity, in the completely submerged body will get completely submerged. Okay? So in the case of a partially submerged body, when this new position of center of buoyancy, if you join a line with the old line of symmetry, you will get a point. It will cut at a point, and that point will be called as metacenter. This is called as metacenter point. Now I'd like to point a very important thing out here, that under stable equilibrium, what will happen? What will happen under stable equilibrium? Under stable equilibrium, this will happen that you can see that this is a point at which weight is acting downward. Weight is acting downward, and we are also having a point at which the force of buoyancy will be acting upward. A force of buoyancy will be acting at this point. For the new position of center of buoyancy, the force of buoyancy will be acting in this point, and the weight is acting along this line. So these two things will be forming a couple. These two things will be forming a couple. The displacement was given in this direction, and these two will be forming a couple which will be in opposite direction, just opposite direction. They will be causing an anti-clockwise moment. An anti-clockwise moment will be formed because of this center of buoyancy and center of gravity. Okay, they will be forming an anti-clockwise moment, and the displacement was in this direction. So because of this anti-clockwise moment, it is also called as restoring moment. It is called as restoring moment. Okay, so a restoring moment will be there which will try to restore the body. Why it is called restoring moment? Okay, so these two forces, force of buoyancy and the center of gravity, they will be forming an anti-clockwise moment, and the displacement was in this direction. So because of displacement, the moment was in this direction. This was a clockwise moment to the body. There will be anti-clockwise moment which will be formed, and because of that, the body will come back to the initial position. Okay, clear everyone? Okay, let me just draw another diagram. Let us say that this was your body. Okay, so this was your body initially. This was, let us say, point G. This was your initial point B. Okay, and because of tilting, this is a new center of buoyancy. This is the new center of buoyancy, B dash. Okay, there will be a force which will be acting in this direction. This will, if you join this, you will be getting a point of metacenter. This will metacenter point. Okay, so there will be buoyant force will be acting upward, and a gravity force will be acting downward. So weight will be acting downward. So they will be forming a clockwise, anti-clockwise moment, and due to displacement, there will be a clockwise moment. So this anti-clockwise moment, which will be formed because of these two forces, the buoyant force and the weight, they will be forming an anti-clockwise moment, which will be also called as restoring moment. And that restoring moment will make the body again go back to the initial position. The body will again come back to the initial position like this. The body will again come back to the initial position like this. This will be center of gravity. This will be center of buoyancy. Okay, so because of this restoring moment, the body will again regain its position, and this type of is called as stable equilibrium. So what will be stable equilibrium of the floating body? The stable equilibrium will be, if you notice here, this metacenter is lying, just metacenter M lies above G. Because the metacenter is lying above the center of gravity, you can see this is a case of a stable equilibrium. Okay, but if you see this condition, in the other condition, if you see the body has got a displacement in this direction, and now the body has, if you see this particular case, if you see that this is a center of gravity, this is a new position of center of buoyancy. So because the new position center of buoyancy is this, if you join this new position center of buoyancy with the line of symmetry, you will be getting this metacenter. This is a point of metacenter. Okay, so if this is a new point of metacenter now, you can say that M lies below G. M lies below center of gravity. Because metacenter is lying below center of gravity, then in that situation a clockwise moment in same direction, जिसमें displacement हुआ है, in that same direction you will be getting a clockwise moment. Okay, And because the moment which have been formed because of the new center of buoyancy force and center of gravity, the moment is in the same direction in which displacement has taken place, there is no chance that body can come back to the initial position, and this will be called as a unstable equilibrium. This will be called as unstable equilibrium. Clear everyone? Here you can, the point which is to be noticed here is, here M lies below G. M is below the center of gravity. If M lies below center of gravity, if the metacenter is coming below center of gravity, then that will be unstable equilibrium. And if M lies above G, if M is above G, then that will be a stable equilibrium. Okay, clear everyone? So because of this unstable equilibrium, an overturning moment will be given formed, and because of that the ship will not be able to come back to the initial position. Okay, clear everyone? Is it clear everyone? So in this particular condition, in the unstable equilibrium, the body will not be able to regain its position, and it will get turned in the same direction in which the disturbance has been given, in which the displacement has been given. So there will be no chance that body can regain its position because a moment will be given to the body in the same direction. Exactly, the shortcut is very correct, very good. So the stability condition point out here is, for a floating body to be in stable equilibrium, M should be above point G. The metacenter should be above the center of gravity. Or we can say that what is the meaning of GM? GM stands for metacentric height. GM is metacentric height. I will tell you what is metacentric height, don't worry. GM is metacentric height. So what is this metacentric height? I will be telling you very shortly. Just wait for 1 minute. Okay. So there are two conditions for stable equilibrium. One condition is simply that is a theoretical condition, that M lies above G, then that will be stable equilibrium. Other condition is, if metacentric height is positive, if metacentric height comes out to be positive, this is a theoretical condition. This has to be calculated theoretically. Theoretically, if metacentric height is positive, comes out to be positive, then that will be a stable equilibrium. So there are two conditions of stable equilibrium. One is if M lies above G, or we can say metacentric height is positive. The other is unstable equilibrium of a floating body or partially submerged body when M lies below point G. If the metacenter lies below point G, then the body will be under unstable equilibrium, or metacentric height is negative. If metacentric height is negative or M lies below G, it will be unstable equilibrium. And the last one is neutral equilibrium. Neutral means simply that both point M and G both are coincident. That means both lie at same point. Under that situation, the metacentric height will be 0. Under that situation, the body, when given a small displacement, it will come to a position where we can say that it will come to a new position, but it will not be able to come back to the initial position. Okay, so at that new position, the body will not be able to, it will not be, neither it will be stable, neither it will be unstable. It will be neutral condition. Okay, now you must be thinking, sir, what is this GM, metacentric height? How can you find that GM? So it is very simple to find the metacentric height. Let us say that this is point M, this is G, and let us say this is the metacentric height. So it is very obvious that GM will be equal to BM minus BG. GM will be equal to BM minus BG. If you see this diagram clearly, the metacentric height, that is GM, if you have to find this value of GM, it will be simply equal to, if all these points lies in a single line M, G and B, if they lie in a single line, let us say, in that condition, if you have to find the value of GM, it will be simple. You have to subtract from BM, you have to subtract the value of BG. If you subtract this point line, this difference from this total, you will be getting the value of Flow with same position means neutral. See, in the case of a neutral equilibrium, the neutral equilibrium is that, let me make you understand the meaning of the stable, unstable or neutral equilibrium. Let us say if we are having a body like this, okay, and if I am having a ball at this position. Now if I give a small force with the ball, what will happen? This ball will go to the some position and will never be able to come back to the initial position. So that will be called as an unstable equilibrium. If this is a position of a body on this type of surface, then what will happen? If I give some force on this ball, if I apply force on the ball, the body will go to this position and again it will go to this position. It will oscillate and ultimately it will come back to the initial point, that is called stable equilibrium. You must have played this type of games, right? And if you are having a plane surface like this, if I have a body right here, if I apply a force to this body, what will happen? I know that this body will not come back to this same position, but after moving to some point, it will come to rest. It will come back to the rest at some point. It will not come back to this same position. So we cannot call it as a neutral, we cannot call it as stable equilibrium, but because it will stop after some time, that will be a neutral equilibrium. So this is how you can understand the differences between stable, unstable and neutral equilibrium. Unstable means whenever a force is given to a body, the body will never be able to regain its position. And it will move in the same direction in which the force has been given. It will continue to move in the same direction in which force has been given. In the case of neutral equilibrium, when you give a force to a body, it will stop after some time. In the same position, in the same direction, in the same position it will stop. Okay. That is called neutral equilibrium. See, that is just an example. That is just an example to tell you the unstable and stable equilibrium with the help of this method. Let us say we are having a ball kept on this type of surface, a concave surface. Having a ball on a concave surface, having a ball on a flat surface, or having a ball on a convex surface. It is just an example to show you the neutral and we can say neutral, stable and unstable equilibrium. So what I was telling you, what is the metacentric height? Metacentric height is simply equal to the difference of the Bm minus Bg. What is the value of Bm? Bm is equal to moment of inertia divided by moment of inertia of the body, moment of inertia of the surface of the body, top surface of the body, okay, divided by the volume of displaced fluid minus what is Bg? Bg is actually the centroid of the displaced fluid, minus Bg. So we can solve some numerical on that, and on the basis of that we can figure it out. How can you find the value of this moment of metacentric height? I have to tell you a very important point on this point here, that what is the moment of inertia? Let us say we are having an example of a ship. Let us take example of a ship. Okay. Now I have to tell you a very important point that is important to understand. What is the moment of inertia? Okay. So let us say this is a floating body, this is a floating ship. Okay. So what is the minimum moment of inertia? Let us say if I just extend this body, if I project this body like this, so body will actually undergo projection like this. So moment of inertia simply means that moment of inertia of the body which is contact with the surface. Moment of inertia of that portion of body which is in contact with the surface. For example, let us say this is a body which is having some D, this is dimension D, this is B. Now this body will be having, if you look at this body will look like this. The top view of the body will look like this. So what will be the moment of inertia? There will be two moment of inertia actually. There will be two moment of inertia actually. One moment of inertia will be along the longitudinal axis and one moment of inertia along the lateral axis. One moment of inertia will be along the longitudinal axis, one will be along the lateral axis. Okay, so there will be two moment of inertia. One moment of inertia will be, let us say this is axis, this is the y axis. So moment of inertia about the axis will be equal to b d cube by 12. Moment of inertia about the y axis will be equal to d b cube by 12. Now you must be thinking which moment of inertia will be kept in that position. When we have to find the metacentric height, which moment of inertia will be kept here? Minimum moment of inertia will be kept in this formula. What is the minimum moment of inertia? You have to put the minimum moment of inertia. What? You have to put the minimum I-axis and I-y-y. You have to put the minimum of these two. Minimum value of moment of inertia. Why we have to put the minimum value of moment of inertia? Why? It is a very simple logic behind that. If you understand the design of the ships, the ships have been designed on the basis of a very simple thing. Which of these two will be minimum? Which will be minimum in this case? Yes, which will be minimum? BD cube by 12 will be minimum, or this DB cube by 12 will be minimum? This will be the minimum one, right? So I have to point you one very important thing is that what is the meaning of this minimum moment of inertia? Let us take example of a ship. Let us say we are having a ship. So generally, if you say, let us say this is your ship. So do you remember that if you have seen this thing in some movies, whenever there is a displacement in the ship in the ocean, you will find that ship basically oscillate. Ship कैसे करता है? ऐसे करता है. It will oscillate like this. If you have traveled in the ship, कभी नाव में बैठे हो, if you have sit any boat also, not in the ocean, maybe you must have traveled in a boat. So you must have feel that whenever there will be some displacement in the boat, it will be having a displacement like this. It will be having a displacement in the lateral direction like this. It will never have a displacement in this direction. Will it be having displacement in this direction? No. It will be having displacement in this direction along the left and right axis like this. Or ship or boat will always be having displacement like this. It will never have a displacement. It will be having less chance of displacement will be in this direction. Right? So what is the meaning behind that? So there are two things. One is rolling, and other is called as pitching. There are two things which is important: rolling and pitching. So let us say we are having a body. Let us say we are having a body like this. Let us say we are having a body like this. To get more clarity, let us understand that this is a body. Okay, what is the meaning of rolling and pitching? So basically, this is a longitudinal, let us say, longitudinal axis, and this is a lateral axis. I have to make it in the between actually, somewhere in the center. Okay, this is a longitudinal axis, this is a lateral axis. So in the strength of material subject, you must have studied about a very important thing, that if you are having a rectangle like this, which moment of inertia will be minimum? If you have to find the moment of inertia, which moment of inertia will be minimum? This moment of inertia will be minimum. So moment of inertia, or we can say oscillation of a body or ship about longitudinal axis is rolling. Oscillation of a body or ship along the longitudinal axis is called rolling, and oscillation of a body. Hi Sudarshan, very good evening. Welcome to the session, and also those who have recently joined me, please like the session also. Oscillation of a body or ship along lateral axis lateral axis is rolling, sorry, is pitching. So let us say this is your basically if you must have seen that if the ship is having oscillation in the longitudinal direction along the length, then it will be called as rolling, and if it is having along the lateral direction, it will be called as pitching. So one important thing I have to tell you that moment of inertia of pitching is always greater than moment of inertia about rolling. Moment of inertia of pitching will always be greater than moment of inertia of rolling. Now the question is, if moment of inertia of pitching is greater than moment of inertia of rolling, then for design of ship and for calculation of metacentric height, which moment of inertia should be taken into consideration? For design of ships, which moment of inertia should be taken into consideration? Into consideration for stability. Consideration for stability. Tell me. This is a very simple question. This is a very logical question. If anybody is from the design, if you have studied from the design, machine design subject, there also we take something called factor of safety, right? So in factor of safety, we notice a very important point that factor of safety is always given to, we always give factor of safety to the minimum requirements, right? For example, in this condition, if your ship is stable in the rolling condition, then no point that ship will not be stable in the pitching condition. That means if your ship is stable in the rolling condition, then always your ship will be stable in the pitching condition. Ships are designed in rolling condition, or we basically for design condition we take the minimum design standard, because your in rolling condition your ship has got minimum less moment of inertia, so we'll be taking the minimum in moment of inertia, which is moment of inertia of the rolling condition. So during the design of the ships, this for stability, especially for the stability condition, we'll be taking the moment of inertia in the rolling condition. This moment of inertia has to be taken, because if your ship is stable in the rolling condition, then definitely it will be stable in the pitching condition. Is it clear to everyone? If your ship is stable in the rolling condition, it will definitely be stable in the pitching condition. Clear? So that is a very important thing. So whenever for design of the ship, we have to take moment of inertia will be equal to moment of inertia of the rolling condition divided by volume of displaced fluid minus Bg. Okay, clear everyone? If we have to design the ships, then moment of inertia of rolling will be taken into consideration. That is about the longitudinal axis. This moment of inertia will be taken into consideration about this axis. So if this is H and this is B, then moment of inertia, which moment of inertia will be taking? The moment of inertia will be for rolling will be equal to, for moment of inertia of the rolling will be equal to H B cube by 12. This moment of inertia will be taken into consideration. Clear? So very important point I have to make you understand that let us understand it with the help of a question. Let us understand these concepts with the help of two to three questions, and you will get more clarity about it. Let us solve few questions on that, and you will be having more clarity about what we have just studied. Okay. So this is the first question that we are going to understand here. For the density of a metallic body which floats at the interface of the mercury of specific gravity 13.6 and water, such that 40% of its volume is submerged in mercury and 60% in water. So we are having basically we are having a metallic body. We are having a metallic body like this. It is having some volume V. Okay, and this body is in such a way that 40%, 60% of the body is submerged in 60% of the body is submerged in 60% of the body. 60% of body is in water. This is water, and 40% is submerged in mercury. 40%, let us say 40% is in mercury. 40% this body is in mercury. So this is mercury and this is water. So tell me, what will be the density of the body? You have to find the density of this body. This question comes in the exam many times, and there is a very good concept here that you have to understand for solving this question. So how can you solve this question? This body, this metallic body basically floats at the interface. This body is basically floating at the interface of both mercury and water. Okay. So tell me, what will be the density of the body? Prateek has got the answer 6040 kg per meter cube. Yes, very quick, Prateek, very good. Everybody tell me the answer quickly. You have to find the density of the metallic body. I think some of the students have asked this type of question in the exam in the last session. I think few session I have taken, that if this body, if there is a body which is basically in contact with two fluids, and if you have to find the density of the body, then how can we find that? So basically, if you see our body, this is our body, let us say. So because this body is partially in contact with water and partially in contact with mercury, there will be some force of buoyancy acting upward due to water, and there will be some force of buoyancy acting upward due to mercury, and there will be some total weight which will be acting somewhere at, there will be some weight which will be acting downward, W. So we can say that in this condition, the weight of the body will be equal to, because it is a floating body, the weight of the body will be equal to weight of force of buoyancy, we can say force of buoyancy. Yes, you can apply the principle of flotation. Now there are basically, there will be two force of buoyancy. One will be the force of buoyancy due to water, and one will be the force of buoyancy due to mercury. The force of buoyancy due to water will be equal to what? As you know that force of buoyancy due to water will be equal to density of the water into G of water into volume of displaced fluid. What is the volume of water? Let us say total volume of body is V. Total volume of body is V here. So volume of body in water will be equal to what? 0.6 V. And volume of body in mercury will be 0.4 V. That will be 0.6 V. Similarly, the force of buoyancy of mercury will be equal to density of the mercury. Density of mercury. Very good, very good. Rutik, you have given the right answer. Mohit has given the right answer. Pratik has given the right answer. Vikas has the right answer. Very good. The density of the body will come out to be 6040 kg per meter cube. Very good. So density of the mercury into G into what is the volume of the mercury in the water, volume of the body in mercury, that is 0.4 of V. Next thing you have to simply do is weight of the body will be equal to what? Density of the body into G into volume of body, right? And that will be equal to density of water, which is 1000 into 9.81 into 0.6 V, plus density of mercury is equal to what? Specific gravity is 13.6. So it will be 13600 into 9.81 into 0.4 V. If you solve it, you will get, this will get cancelled out. G will get cancelled out both sides. V will also get cancelled out. You will get the density of the body will be equal to this will come out to be 6040 kg per meter cube. Is it okay with everyone? Clear? This type of question comes into exam. It is very important concept. Next question is the radius of gyration of the floating ship under rolling is 10 meter. I forgot to tell you one important formula. There is a term called time period of oscillation. Time period of oscillation. Especially for the condition of a floating body, we find the time period of oscillation. This time period of oscillation is equal to 2 pi under root of k square. K is the radius of gyration into g into metacentric height. Okay, so basically this is a formula for time period of oscillation, and this formula, one important thing is important. Time period of oscillation is a very important parameter, and if you notice here that time period of oscillation is inversely proportional to metacentric height. If metacentric height is more, time period of oscillation will be less, and if this is less, it will be more. So my dear students, I have to point out a very important thing here. In the case of the warfare ships, the stability is more important concern. For warfare ships, the metacentric height should be more for more stability. Sorry, metacentric height should be less. Metacentric height. GM should be less. This quantity should be less. Sorry, this should be less. It should be less for more stability. And for passenger ships, because for passenger ships, comfort is more important. So for passenger ships, the metacentric height should be more, so that time period of oscillation is less. Okay, is it clear to everyone? For passenger ships, because for passenger ships, the comfort is more important. And for warfare ships, the stability is more important. So passenger ships, basically, the time period of oscillation should be more, because if more oscillation will be there, okay. Is it clear to everyone? Sorry, I think I have done some mistake here. This has to be high. Sorry, for warfare ships, the stability for it will be high and should be less here. Yes, this will be thing here. Okay. So basically जो ships आपके war के लिए यूज करे जाते हैं, okay, war ships के लिए आपकी metacentric height ज्यादा होनी चाहिए. It should be more for stability. More will be the metacentric height, more will be the stability for warfare ships, because warfare ships are basically designed for stability, so that the ships do not basically, because warfare ships में अगर stable नहीं होगा, then it will create a problem. Okay. So warfare ships are basically designed for stability, so that this oscillation should be less. While for passenger ships, your comfort is more important, and in the case of this, your metacentric height should be less. और oscillation इतना important है कि oscillation आपने देखा होगा कि passenger ships, if you travel in a cruise ships, basically you will be feeling some little bits of oscillation, oscillation will be there, especially if you travel by a cruise ships and all. Okay, because in that passenger ships your comfort is important, but in the case of warfare, stability is important. For more stability, the metacentric height should be more. In this condition, the rolling time period you have to determine. It will be equal to 2 into pi into under root of k. K is the radius of gyration. You have studied about the radius of gyration in the engineering mechanics subject. Okay, this is radius of gyration is equal to root of minimum moment of inertia divided by area. This is the formula for radius of gyration. So radius of gyration is equal to minimum moment of inertia divided by area, square root of that. That is called radius of gyration. Here it is equal to 10 square divided by g. We can take 10 into 1. This will simply get, you'll be getting this value. This will be equal to 2 pi into root 10. What is the answer you are getting? Tell me. What will be the answer? You will be getting 19.86 seconds. Approximately that will be 20. Okay, clear everyone? Next question. A floated body is shown in the figure below. The metacentric height is. A floated body is shown. If there is a body which is floated or if it is floating. Hi Ajit, very good evening. Welcome to the session. And those who have joined me for the session, then also please like the session also. Those who have recently joined me for the session, please do not forget to like the session. What is the answer for this question? Hurry up, tell me. Yes, hurry up, be quick. A floated body is shown in the figure below, the metacentric height. Yes, come on, tell me the answer quickly. So now you have to apply the concept of that, whatever I have taught you. You can see that for this block, the total height of block is equal to what? The total height of the block is 50 mm, let us say. The width is given as how much? The width is given as 100 mm. The length is given as 70 mm. So you can easily find the value of volume of the body. The volume of body will be equal to what? Volume of body you can easily find. But here you don't have to find volume body. Volume body will be equal to, volume of the body will be equal to 50 into 100 into 70. This will give you the volume of the body. But here you don't have to find the volume of the body. Okay. Radius of gyration means, Naveen, radius of gyration you must have studied in the engineering mechanics. It is same radius of gyration. Okay. You have to find the metacentric height. Metacentric height will be equal to, let us say this is, we have point G. The center of gravity of the body will be somewhere here. Let us say G. The center of buoyancy of the body will be somewhere here. Let us say B. And there will be some point of metacenter. Let us say this is point M. In that condition, what will the BG? The BG will be equal to what? Sorry, B, I have to draw it a little bit. BG will be equal to what? BG will be the distance between so my dear, the BG will be equal to this height, this total height, whatever is the total height. The center of gravity will be lying at for this whole body, the center of gravity will be lying at a distance of 25. Okay. And the moment of, what is the value of BG? The BG will be equal to what? This is if 25, this is 30. Then for this particular body, the B point will be lying somewhere at this point. Let me just show you the value of B. Because center of gravity is the centroid of the whole body. Center of gravity is the centroid of the whole body. For this whole body, it will be lying exactly somewhat here. This will be the point of center of gravity. The centroid, center of buoyancy is the center of gravity of the displaced fluid. This is the height of the displaced fluid. What is the height? Half of this. This is at this particular point will be center of buoyancy. So center of buoyancy is lying at a distance of 15. Center of gravity will be equal to what? It will be equal to 25 minus 15. This will give you 10 mm. Okay, because this distance is equal to what? 15, 25. This distance is equal to what? 15. So center of gravity will be equal to what? 25 minus 15, which will be 10 mm. This is the value of BG here. Moment of inertia will be equal to what? It will be equal to 100 into 70 cube by 12. This will give you the moment of inertia. Okay, because minimum moment of inertia will be equal to what? Because moment of inertia is the moment of inertia of that body which is in contact with the surface. If you see the top view of the body will look like this. The top view of the body will look like this. This will be 100, this will be 70. So moment of inertia will be equal to what? Moment of inertia will be about this axis. About this axis. So it will be equal to 100 into 70 cube by 12. And volume of displaced fluid will be equal to what? Volume of displaced fluid will be equal to height of the displaced fluid is equal to 30. The width is 100 and the length is 70. This will give you the moment of inertia of the displaced fluid. Come on, tell me what is the answer. Hurry up. Yes. So volume of displaced fluid will be equal to 21 into 10 power 4. Volume of displaced fluid will be equal to 21 into 10 power 4 mm power 4. The moment of inertia will be getting as 285.383 285.83 into 10 power 280.83 into 10 power 4 10 power 4 mm power 4. Okay, so because you have got everything, you just need to put the value here. This will be moment of inertia. This will be 285.83 in 10 power 4 divided by V, volume displaced is 21 10 power 4. This will get cancelled out, minus 10. If you solve it, you will be getting the answer. What is the answer you are getting? B. Are you getting the value B, everyone? 3.61. Very good, very good. Everyone is getting the same answer, 3.61. You are getting 3.611 mm. Okay, so this question tells you, explain the concept of how to find the metacentric height for a floating body. So always, whenever you have to find the moment of inertia, you have to find the moment of inertia about that portion which is having least moment of inertia. If you find the moment of inertia about this axis, the moment of inertia will be more. You don't have to find the high moment of inertia, you have to find the minimum moment of inertia. Okay, so that is why we have to take this moment of inertia, minimum one. Volume of displaced fluid means the volume of that fluid which is in water. This is the height of that. This is the width. Sorry, length 100, and the width is 7. This is 70. Length is 70. This is 100. Okay, so this will give the volume of displaced fluid. Now let us understand the concept of acceleration. Before I move further, I have to tell you the fluid acceleration. In the fluid kinematics, this topic of fluid acceleration is all important. What is this fluid acceleration? This is also given in the GATE syllabus, the topic of fluid acceleration. So now you have secured your 2 marks 100% from the topic of buoyancy, because the stability condition of a floating body is important for your exam. Okay, if a question will come, you can definitely solve that question. Now another topic which is important is fluid acceleration. Fluid acceleration is a topic given in the GATE syllabus. This topic simply tells you that what is acceleration you have studied in the engineering mechanics. Rate of change of velocity with respect to time. That is acceleration. But if you talk about a fluid, you have studied that in a fluid flow. In a fluid flow, you have studied about 2 different types of flow. One is steady flow and other is uniform flow. What is the meaning of steady and uniform flow? The steady flow means if the fluid properties do not change with respect to time at a particular location, with respect to a given location, if the fluid properties are not changing with respect to time, because here time constraint is important. At a given location, let us say this is a container and we are having a fluid at this particular point, at a given fixed point, if the velocity is not changing, it is not a function of time, or if pressure is not a function of time, it is not changing with respect to time. Okay, in that situation that will be a steady flow. What is the meaning of uniform flow? If the fluid properties at a given time are not changing with location. Fluid property at a given time are not changing with location or position, then that is called as uniform flow. At a given time, if the fluid properties are not changing with respect to location in the x direction, y direction, z direction, if the properties are same, then not changing, that is called uniform flow. The opposite of a steady flow will be unsteady flow. It means if the fluid properties are changing with respect to time, that will be called as unsteady flow. If the fluid properties are changing with respect to location, that will be non-uniform flow. Okay, so unsteady flow means fluid properties changes with time. Fluid properties changes with time. At a given location, fluid properties are changing with time. And non-uniform means fluid properties are changing with location. ठीक है? Changes with location or position. Okay. Now I have to tell you a very important point here. Very important point. If you talk about fluid acceleration, your fluid acceleration composed of two parts. Your total fluid acceleration is composed of two parts. One is local acceleration or temporal acceleration. Local or temporal का मतलब होता है which is changing with time, which changes with time. This acceleration is that acceleration which is coming because velocity is changing with respect to time. That acceleration is called local acceleration or temporal. Temporal means time, which is a function of time. Okay, so this will be acceleration as a function of time. Acceleration which is function of time, which is due to velocity changes with time. Because velocity is changing with time, that acceleration we getting will be the local or temporal acceleration, and this is equal to dv by dt or du by dt or dw by dt. If the velocity is changing with respect to in the y direction, that will be dv by dt. If it is changing in x direction, that will be du by dt, and if it is changing in z direction, that will be dw by dt. Another acceleration is called as convective acceleration. Convective acceleration is that acceleration which is due to the non-uniform flow. Because of the non-uniform flow nature of the flow, that will be called convective acceleration. And this acceleration will depend on the changes with respect to location. For example, in x direction, convective acceleration will be equal to u times of del u by del x plus v times of del u by del y plus w times of del u by del z. This will give you the convective acceleration in the x direction. In y direction, this will be equal to u times of del v by del x plus v times of del v by del y plus w times of del v by del z. This will be giving you the convective acceleration in the y direction because this is a function of location. And in z direction also you can find, in z direction this will be u times of del w by del x plus v times of del w by del y plus w times of del w by del z. Clear everyone? If we combine these two, so we can say that total acceleration is the sum of, if we combine these two, we can say that total acceleration is the sum of local acceleration plus convective acceleration. Can we say that? If we combine these two, we can say that total acceleration is the sum of local plus convective acceleration. But for what? For unsteady and non-uniform flow. For unsteady and non-uniform flow, the total acceleration is sum of local plus convective acceleration. Is it clear to everyone? Is it clear to everyone? Tell me. Total acceleration is equal to sum of local plus convective acceleration for unsteady and non-uniform flow. That means if we have to find the total acceleration in x direction, it will be equal to du by dt plus u del u by del x plus v del u by del y plus w del u by del z. Shivam Prasad, that point is called metacenter, my dear. Okay. In y direction, this will be equal to del v by del t plus u times of del v by del x plus v times of del v by del y plus w times of del v by del z. And in z direction, it will be equal to del w by del t plus u del w by del x plus v del w by del y plus w del w by del z. This is a formula for total acceleration. Now, an important point here is for steady flow, what will happen? For steady flow, local acceleration will be 0. If the flow is steady, local acceleration will be 0. And for uniform flow, convective acceleration will be 0. Tell me, is it correct or not? If the flow is steady, then local acceleration will be 0. And if the flow is uniform, then convective acceleration will be 0. Is it correct or not? Tell me everyone. Is it correct? Yes? Tell me everyone. So can I say that for steady flow, if the flow is steady, then total acceleration will be equal to, total acceleration is equal to convective acceleration. And if it is uniform flow, for uniform flow, total acceleration will be equal to local acceleration. But if I combine these two for steady and uniform flow, for steady and uniform flow, tell me what will be total acceleration? For steady and uniform flow, total acceleration will be what? Tell me. For steady and uniform flow, total acceleration will be, yes, for steady and uniform flow, total acceleration will be what? It will be, tell me everyone, all those students who are watching the session, tell me, for steady and uniform flow, total acceleration will be 0. Yes, it will be 0. Why it will be 0? Because of steady, local acceleration will be 0. Local acceleration will be 0 due to steady nature. Due to uniform flow, convective acceleration will be 0. And because of that, for steady and uniform flow, total acceleration will be 0. So my dear student, there is always, because they have mentioned in the syllabus of GATE exam, they will definitely be asking you one question from the fluid acceleration. That is a very important topic. So my dear students, this topic is important and this can come in your exam also. And now let us understand this topic with the help of some questions, some numericals. Okay. So let us solve few questions now. This is question number 1. It is a simple question because we'll be solving with starting with simple, then we'll go for the complicated one. We are having a steady incompressible flow, and for a steady incompressible flow, u is equal to x square plus y square and v is equal to 2xy. What is the convective acceleration along the x direction at the point 1, 1? We are having a steady flow. Steady flow means, if they have mentioned it is a steady flow, they have mentioned it is a steady flow, steady means what? Local acceleration will be 0. Local acceleration will be 0. Obviously baat hai, right? So in that situation, the total acceleration will be what? The total acceleration will be convective acceleration. And they are also asking the convective acceleration for your, for just, they are giving the question also to find a convective acceleration. What will be the answer? Okay, so Pratik has got C, Vikas has got C, Akhilesh has got C. Good. So now the students have got the answer also. Hurry up, come on. And those who have not joined the session, they have not liked the session. Those who have joined and not liked the session, please also like it. Okay, and also share the session. Yes, many of the students have given the answer, that is option C. Good. The right answer is option C. Good. Very good. Everyone has given the right answer. It is very simple. Because you have to find total acceleration in the x direction, that will be equal to u times of du by dx plus v times of du by dy. Why I am not writing w? Because w is not given. They have only given u is equal to x square plus y square, and they have given v is equal to 2xy. Because they have given the velocity only in x and y direction, they have not given the velocity in z direction, the total convective acceleration will be equal to this, right? Because local acceleration is already 0. Local acceleration, which is equal to du by dt, this will be 0 already. Okay, so what will be u? U is equal to this. What is the value of du by dx? Du by dx will be 2x. But you have to find everything at these 2 points. What is the meaning of this point? At x is equal to 1 and y is equal to 1, you have to find. At x is equal to 1 and y is equal to 1, this will be equal to 1 square plus 1 square. This will be 2. At x is equal to 1, y is equal to 1, v will be equal to what? 2 into 1 into 1. This is 2. So u and v will be equal to 2 here. What will be du by dx? It will be equal to du by dx will be 2x. That will be 2 into 1 is equal to 2. What will be du by dy? It will be equal to 2x. This is which is equal to 2. So it will be simply equal to 2 into 2 plus 2 into 2. That will be giving you 8. This is only the simple question we have started. Now we will see some more questions. Next question. Next question. The velocity of the water when the fluid is flowing in a constant diameter pipe is given by. So they have given the velocity of the water when the fluid is flowing in a constant diameter pipe. The velocity I will write it again. It is equal to 8 by t square plus 5t. And they have given this velocity in j direction, in the y direction, meter per second. Okay. You have to find the acceleration at time is equal to 2 seconds. At time is equal to 2 seconds, you have to find acceleration. Come on, tell me. Which acceleration you will be finding here? Tell me everyone. Akhilesh has got the answer as 1 in this question. Yes. Everyone quickly solve this question. Hurry up. You have to find the velocity in which direction? First of all, you have to find the velocity only in the y direction, because they have given the j component of velocity. J means what? In the vector form, j indicates that this is the y component of velocity given. Y component. That velocity is given only in the y direction. In that situation, my dear, this velocity is just a function of time. So we have to find the acceleration only in the y direction. This will be dv by dt plus u times of dv by dx plus v times of dv by dy plus w times of dv by dz. They will be 0. They will be 0 because the velocity is not a function of x, y or z direction. They are only velocity is just a function of time. So this will be 0 because velocity is not varying in the x direction. This will be 0. It is not varying in the y direction. This will be 0. And because velocity is not a function of space coordinate, this will be 0. So velocity will be acceleration will be equal to dv by dt simple. In this situation, this component, this whole thing, velocity v is equal to what? V is equal to 8 by t square plus 5t. So only fun of t. Yeah, exactly. So it will be simply equal to d by dt of 8 by t square plus 5t. 8 by t square, if you do the differentiation, you will be getting minus 16 by t cube. Okay. And this will be equal to minus 16 by 2 t cube. Because if we do the differentiation, it will be minus 16 by t cube plus 5. Now you have to put the value of time is equal to 2 seconds. At time is equal to 2 seconds, it will be minus 16 divided by 8 plus 5, which will be equal to minus 2 plus 5, which is equal to 3. Okay, clear everyone? So the answer will come out to be 3 meter per second square. Next question, the average velocity in a nozzle changes linearly from 25 meter per second at the beginning to 10 meter per second at the end over a distance of 0.40 meter. The magnitude of convective acceleration at the beginning of the nozzle is. The average flow velocity in the nozzle changes from 25 at the beginning to 10 meter per second. So initially the velocity is given as 25. After that the velocity is changed to 10 meter per second. So we are having a nozzle, the velocity changing like this. Now this velocity variation is taking place. This velocity variation is taking place at a displacement of 0.40 meter. This is a displacement given here. You have to find the magnitude of convective acceleration. Convective acceleration you have to find. So how can you find the magnitude of convective acceleration in the nozzle? Convective acceleration will be equal to what? It will be v times of velocity into dv by ds. This will be the convective acceleration. What is the velocity given here? Velocity, initial velocity is 25 here. That will be 25. Change of velocity is equal to what? 25 minus 10. And displacement is equal to 0.40. So it is very simple question. This will be 25 into 15 divided by 0.40. You'll get the answer. What is the answer? Tell me everyone. You'll be getting 937.5 meter per second square. Okay, so this will be the value of the convective acceleration in this question. The answer will be option A. Okay, clear? So because the question comes in the exam from convective acceleration, this is a very important topic, and you find that questions are very simple, very easy, but when the question will come in the exam, you will be it might get difficult for you to understand it. Okay, because they have only asked to find the convective acceleration, so this is how you will be finding the convective acceleration. Because they have asked the convective acceleration at the beginning of the nozzle, so you have to take the initial velocity here, v. Okay. The last question of the session. Last question. The velocity field for a two-dimensional flow is given by. I hope the velocity is visible to you. The velocity field for a two-dimensional flow is given by v is equal to 2xy minus xi minus xy. अगर आपको नहीं दिख रहा है, if it is not visible, I will simply write it again. If you want, I can write it again. This velocity is written here. V is equal to 2xy minus x I minus xy square j plus xy z square minus 2yz plus z k. This is the what written here. Okay, I hope it is visible now. So basically this is the u component of velocity, this is a v component of velocity, and this is a w component of velocity. These are three components of velocity given. You have to choose the correct statement. Now this question is basically as you can totally guess from here, it is a MSQ type question. Okay, so tell me the answer everyone quickly. The third statement is flow is compressible. When we say that flow is incompressible, when flow is incompressible and steady, then du by dx plus dv by dy plus dw by dz is equal to 0. If this condition is not satisfied, then the flow will be compressible. If the flow will be incompressible and steady when this continuity equation is satisfied in the Cartesian coordinates. So the option C can be checked if the flow will be compressible if this is not 0. If the continuity equation is not satisfied, then flow will be compressible. So you can check that. U is given, V is given, W is given. You can find this thing very easily. So you can find the value of for this option C. Option C can be easily checked. Convective acceleration in the x-axis depend on the variation of velocity in the z direction. You have to find the convective acceleration in the x direction. This will be u times of del u by del x plus v times of del u by del y plus w times of del u by del z. So if you find this, you can simply put the values here. You will be getting this answer as u is equal to what? U is given here 2xy. So we have to find del u by del x. Del u by del x will be equal to what? This is u. This whole part is u. This will be getting u. Del u by del x will be equal to 2y minus 1. Del u by del y will be equal to, del u by del y will be equal to what? It will be equal to 2x, and del u by del z will be equal to what? 0. Okay. Similarly, you can find the value of del v by del x will be equal to minus y square z. Del v by del y will be equal to minus 2xyz, and del v by del z will be equal to minus xy square. Okay. The last is you have to find del w by del x. Del w by del x will be equal to yz square. Yz square. Del w by del y will be equal to xz square minus 2z, and del w by del z will be equal to it will be 2x yz minus 2y plus 1. This will be del w by del z. So you have found all the things. Now you just have to simply put all the things in this formula of acceleration. Let me just get a blank slide for solving this question. Okay. So my dear students, the acceleration in the x direction will be equal to what? U. U is equal to what? It is convective acceleration in the x direction will be equal to u. This is 2xy minus x. 2xy minus x. You know, del u by del x. Del u by del x is equal to what? 2y minus 1. 2y minus 1 plus v. V is equal to minus x y square z minus x y square z into del u by del y. First is wrong. I got minus 32. Okay, so let me just give you the solution for this question. The right answer for this question will be option A and B. The right answer for this question will be option A and option B. These are only correct. Only option A and B is correct. So how to solve this question? Let me tell you the solution for this question. If you check du by dx plus dv by dy plus del w by del z, you will find that this value is equal to del u by del x is equal to what? 2y minus 1. dv by dy will be equal to what? dv by dy is minus 2xyz. Minus 2xyz. And del w by del z is equal to what? 2xyz. 2xyz minus 2y plus 1. If you open this thing, you will be getting, this will get cancelled out, this will get cancelled out, and this will get cancelled out. So ultimately you will be getting 0. Because this continuity equation is coming out to be 0, the flow is incompressible. Okay, so option C is not correct. Clear everyone? Let us see how the option D, convective acceleration in the y-axis is this much. At this coordinate, the convective acceleration y-axis is this much. And convective acceleration in y-axis, so we have to find convective acceleration y-axis. So let us find the convective acceleration in the y direction first. So convective acceleration y direction will be equal to u times of del v by del y, sorry, del x plus u times v times of del v by del y plus w times of del v by del z. So just put all the values, will be getting the answer. U is equal to 2xy minus x into del v by del x is equal to what? Del v by del x is minus y square z plus v is equal to minus x y square z into del v by del y is equal to what? Del v by del y is minus 2xyz. See why I am solving this question. Basically maybe this question is big, but this type of question can come in the exam. W is equal to what? W is xyz square minus 2yz plus z into del v by del z. Del v by del z is equal to minus xy square. Xy square. Okay, so if you just put the values 1, minus 2 and 2, if you put x is equal to 1, y is equal to minus 2 and z is equal to 2 in this equation, what you will get? You will be getting this answer as, you will get the y component of velocity acceleration. You will be getting this value as 32. Are you getting this value as 32? Are you getting this value as 32? Everyone tell me. You will be getting 40 minus 64 plus 56. So this whole part you will be getting as 40. This whole part will be equal to minus 64 and this whole part will be equal to 56. You will be getting 32 meter per second square. Are you getting this value, everyone? Y component of velocity acceleration. Yes? Are you getting this value, everyone? Tell me. So you will be getting y component of acceleration as 32 at these coordinates. So option A is correct. Convective acceleration in the x-axis depends on the variation of velocity in the z direction. Obviously, okay, you have got minus 32. Minus 32. Is anybody else who has got the answer? Let me just check this. 2 into 1, 2. Okay. No, that is correct. It will be my z term is minus 8. Please check, sir. No, that is not correct. See, you have to find the convective acceleration at 1, minus 2 and 2. So this will give you the value as, this whole term will be giving you, see, I'm just writing everything. I'm just writing what I have got. Let me just write it. Now you can match it here, okay? Let us write it here. So this will be equal to 2. Okay, this term will be equal to minus 5. Minus 5. This whole term will be minus 5. Into ये टर्म क्या होगा आपका minus 8. Minus 5 into minus 8 plus this term will come out to be minus 8. This term will come out to be 8. Clear? This term, last term will be getting as plus minus 8 minus 8 minus 8 plus 2 into minus 4. Just put the simple values, man. Just put the values. X is 1 here. X is 1 here. 2 into 1 into y. Y is minus 2. So this is 2 into 1 minus 2. That is minus 4. Sorry. And this is 1. Minus 4 minus 1 minus 5. This is minus 5. This is minus y square. Minus times of. See, minus is outside. You don't have to take it into the square. This will be minus times of y square. Y is minus 2. That is 2 square. Minus 2 square is minus 4. This is minus 4 into 2. That is minus 8. Then we have to see this term. Minus x is minus 1. Z is minus 8, sir. Z is minus 8. What is minus 8? You are saying this term will be minus 8. Okay, let me just check that. Okay, let me just check the last term. Okay, no problem. Let me just check the last term. This will be equal to, it is 1 into minus 2 into 2 to the 4. Okay, that will be minus 8. Okay, this term will be minus 8, then minus 2 into minus 2 into 2. This will 2 to the 4 to the 8. 8. So this will come out to be, sorry, this is 2. This will be minus 8. This is minus times of 2 to the 4 to the 8, minus 8. This will be plus 8. Okay, this will come out to be plus 8. Okay, clear. That this will get cancelled out. This will get cancelled out. Okay, got it. Okay, this will be plus 8. Clear. And this is Z. This will be plus 2. Okay, so this will be minus 8. Clear. This will be 40 minus 64, and this will be minus 8. Is it clear now? This is minus plus 8. 0 plus 2 into minus x, minus of 1 into y square. Y square is minus 2 whole square is 4, minus 4. Yeah, this will be minus 8. That will be basically for. Okay, that will be minus 32. Clear. That will be minus 32. Clear. Okay. Yeah, that was a mistake. Actually, that was a mistake. This has to be minus 32. Minus 32. Okay, got it. Totally got it. This has to be minus 40. Either it has to be minus 32 or the answer will not be correct. Okay. This is a lengthy question. It is just to tell you that how this question can come in the exam. In the y direction, this will not be 73. Convective acceleration in the y is obviously not. This is not the answer. This is not the answer. Convective acceleration in the x-axis depends on variation of velocity in z direction. This point number in the x direction, the convective acceleration will be definitely depending on the velocity in the okay. So if you see the acceleration in the x direction, it will be function of the acceleration in the x direction will definitely be a function of the velocity or variation of the velocity in the z direction. Okay, that is also correct. Okay, if you open it, if you write the acceleration in the x direction, that is u times of del u by del x plus v times of del u by del y plus w times of del u by del z. If you write it, you will see that your acceleration will be coming in a function of velocity in the z direction. Okay, so that is also correct. So see, this type of question is just to show you that how the question can come in your exam. Okay, it is just to B point कैसे सही हुआ, du by dz is equal to 0. Convective acceleration in the x-axis depends on variation of velocity in z direction. Variation of velocity in the z direction simply means that if you find the convective acceleration, if you find du by dz, it is equal to 0. So you will find that the convective acceleration, this acceleration in the x direction is just a function of the acceleration in the x direction is just a function of the velocity in the y direction, x direction, because z component of this is 0. This is 0. Convective acceleration in x depends on the velocity, depend on variation of velocity in the z direction. Yeah, velocity is varying in the z direction. Du by dx. Okay, that is also a mistake. Okay, so there is some point of mistake here in this question. So we can say that the question is obviously there is a mistake in the question there somewhere. So I will see that. Let us say that we can see this question for I will check this question. There will be some mistake, okay, and we'll see what correction can be done in this question. Okay, it is not depending on the variation of velocity in z direction. Okay, so because du by dz is equal to 0, so this is not correct. Does not depend होना चाहिए. If which mistake, there is a mistake in the options. We can take it for correction. Okay, this question is taken for correction. So I have to see this question. Sorry.